In this video, we'll be going over Chapter 5, Section 1, where we look at atoms, bonding, and the periodic table. So the first thing we're going to talk about, and the main thing we're going to talk about today, is valence electrons. We've kind of talked about them some in Chapter 4, but just to reiterate again. Valence electrons have the highest energy, and they are held the most loosely on an atom. So they are in the outermost ring. Okay, so valence electrons are in the outermost ring when we're looking at like the Bohr model. The number of valence electrons of an atom determines some properties, and it can be including how it's going to bond with other atoms. So depending on how many valence electrons it has, that tells you how many other elements it's going to bond with, or how many bonds are going to happen, or anything like that, because it's going to be how many electrons do they need to share or take to get to 8. So there's a pattern we can follow that you're going to want to add to your periodic table. So each element has a specific number of valence electrons that ranges from 1 to 8. The pattern, group 1, they all have 1 valence electron. Group 2, they all have 2. Then we skipped over to group 13. They all have 3, 14 has 4, 15 has 5, and so on. So you're going to want to add this to your periodic table in your science notebook. Just put like valence electrons in like a specific color and then put those numbers above the groups just to help you remember this. Elements within the group all have the same properties. We've talked about that, and so the same number of valence electrons just kind of falls into that. We can represent these using electron dot diagrams. So let's do a couple examples of what that means. So if I look at hydrogen, which is in group 1, hydrogen only has 1 valence electron. So its electron dot diagram would just be an H with a dot above it. It's easiest to start at the top and then work in a clockwise pattern as you're adding valence electrons. So for example, carbon is in group 14, so it has 4 valence electrons. So if we start at the top, 1, 2, 3, 4, there's 1 on each side in like a pattern. So we're going to end up with some here, some on this side, and some on the other side. But if you start at the top, and then you go in a clockwise pattern as you add them. Another example of this could be like chlorine. Chlorine is in group 17 and has 7 valence electrons. So if I start 1, 2, 3, 4, then I just continue 5, 6, 7. So notice how they're in like groups of 2, where you can end up with 2 on the top, 2 on the right, 2 on the bottom, 2 on the left. Except this only has 7, so by putting them in that clockwise pattern, I am going to end up with one side that only has a singular valence electron on it. Okay, but you're going to want to start at the top and then add 1 as you go around in that pattern. So you can do that for any of the ones in these groups with the clue or with the patterns. In the center, you're going to have to pay more attention to, on your periodic table, your list of electrons in the top right of each element, and you would have to see how many it has in its outermost shell, because it doesn't follow the same kind of a pattern as groups 1 and 2 and then 13 to 18 do. Okay, but this is how you draw your electron dot diagrams. Start at the top, add them one at a time, going in a clockwise pattern, where you would end up with, at most, like if it had 8, we would have 2 here, 2 here, 2 here, and 2 here. Okay, so atoms tend to be more stable when they have 8 valence electrons. The magical number that they want to have is 8. They want to get to 8 because then they don't need to share with anything to fill that shell. Examples of this are like neon, argon, krypton. They all have 8 valence electrons, and they're all very unreactive. Okay, so they're in that noble gas on the right-hand side that we have talked about previously, and they are unreactive because they already have their 8 valence electrons and don't need to bond with anything to share to get any more. Chemical bonds, where they're bonding together, are going to be how they share their electrons, and they're going to do one of two things. If they only have 1, 2, or 3 valence electrons, most likely they're going to want to get rid of those and go down to having none. So they're going to want to share those with something else that needs 1, 2, or 3 so that they only have 0. So that you're either going to be at 0 or 8 to be happy, basically. If you have 5, 6, or 7, you're going to want to bond with those things that have 1, 2, or 3 because you're going to want to get up to 8 because you're closer to 8. So when they're sharing and they're trying to get to that magic number, you can think of it like they're either trying to get closer to 8 or they're trying to get closer to 0, depending on how many valence electrons they have. And they do that by bonding together and sharing them. All right, that wraps up lesson 5.1 on atoms, bonding, and the periodic table.